Welcome you all for another one lecture. So in electrostatics, we have seen the basics of this electrostatics and also the different laws like Gauss law and also Coulomb's law. And in the previous video, we have seen about the vector form of Coulomb's law. Okay, now let us see a problem related to that. So determine the electric field intensity at the point P due to the point charge of 5 nanocoulomb at Q. Okay, so the point is given inside 0 0.2, 0 0.1, minus 2.5 in air. Okay, so we have drawn it as a diagram. So Q is one point and P is another one point. So whether they have the coordinates along x, y, z. So at P it is minus 0.2, 0 and minus 2.3, and for Q it is 0.2, 0.1 and minus 2.5. Okay, now let us see the solution of this. So you know that the electric field density, it can be given by E is equal to just Q divided by 4 pi epsilon naught r square into it is into a r vector. So the unit vector AR is given by r of there is a distance between these two charges Q and P. So r QP vector divided by modulus of r QP vector. Okay. So this is how you can find the unit vector. Let us do the further calculation. So this RQP can be written as RQP can be written as RQP. So that is written as RP vector minus RQ vector. You know the points of P and as well as Q. So therefore you can write that easily here. Let us move to next page. Okay, so here, so that is equal to minus 0.2 AX vector plus 0 AY vector minus 2.3 AZ vector. So this is RP, so minus RQ, that is given by minus 0.2 AX vector plus 0.1 AY vector minus 2.5 AZ vector. So divided by modulus of RQP. Now let us solve this. So minus 0.2, so here also minus 0.2, so it is minus 0.4 AX vector. So here it is plus 0, so minus 0.1. Sorry, it is minus 0.1 AY vector So minus 2.3, and here it is minus 2.5. So minus, so minus 2.3. Okay, so if you multiply this minus inside, here it becomes plus. So minus 2.3 plus 2.5. So it is plus 0.2 A Z vector divided by. Now we know the value for RQP. So we can take the modulus. So 0.4 square plus 0.1 square. Don't bother about the sign here. Plus 0.2 square. Okay. So finally you will get minus 0.4 AX vector minus 0.1 AY vector plus 0.2 A Z vector divided by. So after solving this, you will get 0.45. Okay. So here the unit vector, this is AR, that is equal to. So dividing this by commonly by 0.45, you will get minus 0.885 AX, then minus 0.222 AY, 222 AY, then plus 0.444 AZ. Okay, so we got this unit vector AR. Now we have to substitute in the formula. E is equal to Q by 4 by epsilon naught R square. Okay, so we know the value for Q, that is given as 5 nanocoulomb. So 5 into 10 power minus 9 divided by 4 into pi. So 4 into 3.14, 4 into 3.14 into the constant epsilon naught value is 8.854 into 10 power minus 12 into R square. So the R square value is 0.45 whole square. 0.45 the whole square. Okay. So after substituting this, one more is, that is the unit vector, as it is 0.88 AX vector minus 0.222 AY vector plus 0.444 AZ vector. So after dividing this value, for this you will get a value like this, that is 221.99 multiplied by the vector value minus 0.888 AX vector minus 0.222 AY plus 0.444 AZ vector. Now you multiply this inside. After multiplying this, you will get minus 199, sorry, minus 194.06 do AX vector minus 49.266 AY vector plus 98.532 AZ vector. Okay, so this is the value for electric field. So first we have to find the unit vector, and then substitute the values. Finally, we will get a vector for E, that is the electric field E vector. So this is about the problem. Okay, right. So just an example problem. Now let us move on to the next topic, that is the types of charge distribution. Types of charge distribution. Types of charge distribution. How the charges will distribute. So already we have seen about this. You know that there is point charge. Uh, Types, let us write one by one. Point charge. So that is zero dimension. So when you write in the when you take the charges in one axis, single axis, then it is line charge, the line of charge, which may be in any one of the axes, x, y, or z. Then two dimension means it's in the plane, the charge is on the plane, so it is surface charge. And the last one is in three dimension, that is volume charge. So you should know about this clearly. So first let us see about the point charge. So that is quite normal. We will see um, to mention a charge at a particular point. So here this point charge is mentioned as Q. So here this can be mentioned as if the dimensions of the surface carrying charge are very small, or very small compared to the region surrounding it, compared to the region surrounding it. Then the surface is considered as a point. Which means there won't be more number of charges, only few charges will be there. Joined, and the charge and the corresponding charge is called as point charge, and the corresponding charge is called point charge. Point charge. So here you can mention, if you consider any one of the point, this is Q1. So this is positive. If it is negative, it is mentioned as Q2, like this. Okay. Now let us see the next one, that is line charge. Now let me write as a hint. Okay. So line charge. So the point charge may be spreaded if it is spread all over the line. So it forms a line. So line of that means an array of point charge along a line. Okay, all over along a line, only one line. Okay, so which may be finite or infinite, which may be finite, that means the distance may be known or unknown. Be finite or infinite. Or infinite. So such uniform distribution is along a line is called as line charge. So here it is mentioned as rho L is equal to total charge in Coulomb divided by total length in meter. So line of charge, it is given by Coulomb per meter. Okay, so Q is equal to integral of rho L into dl. So a line of charge. Like this. So it is given by rho of L. Okay, right. Then surface charge. Surface charge. So you know that this should be in the plane. The charge is in the plane. So two axes are here, x, y, or y, z, any two. So this is given by rho s. So the total charge in Coulomb, total charge in Coulomb by total area in meter. So area, you know, it is meter square. So square meter. So you can write it as Coulomb per meter square. So Q is equal to integral of surface dq is equal to then rho s into ds. So the last one is, so here this is volume charge. So the similar kind of definition. So the total charge in Coulomb divided by total charge, total volume in Coulomb, sorry, cubic meter. So rho V is equal to Coulomb per meter cube. So Q is equal to integral over V, rho V into dV. So this is of any three dimension. So if you consider a cylindrical or cube or whatever it be, completely filled with the charges, and it is the volume charge. So very simple. Okay, so that's all about today's topic. Then again we will see some problems in the next class. Thank you, students.